Hey guys, and welcome to a defense creation section. Maybe uh, most of them will be new to this topic, hooking and unhooking. Maybe some of them heard what's the term of hooking. Um, we will be um, will be use hooks word in multiple times, even in fish, when we'll be going for fishing in harbor or something. But in cybersecurity term, it will be like pretty different, the hooking part. Let me show you what was what will be the hooking. Basically, the hooking is used by the EDRs, antivirus softwares, as well as the threat actors. Okay, both the terms like the hooking method will be used by threat actors to develop their malwares to um, evade the EDRs and antivirus platforms, as well as uh, the um, the different tools. Okay, like EDRs, antivirus softwares, or whatever. So the basically the hooking was introduced by uh, introduced by for programmers. So let's take an example. Uh, there is um, there is a programmer who developed an application and he left their organization, and so a new developer has been joined, and the new developer was unable to see the code. So what was the code he was used, and how he written the program, and how he coded the application. He doesn't know what was going on inside because the code was not visible. Okay, so at this time he needs to give some updates. He needs to change some options, or he needs to add some options in the program. So for that we can use a hooking. Okay, basically hooking will change the execution flow of a program. And yeah, let's I will give a small example. Okay, so you are playing some game, and your health is important there. There was a fighting game, and so your health will be, if the health will be 100, you can fight more. But when the health will be reduced to less than 10, you have a lesser time to fight, right? So what we can do, we can hook the game, and we can change the execution flow. So whenever you hit by a target, whenever you hit by some gun or sniper or something, still you will be having 100% health. Okay, so you hit multiple times, like even 100,000 times, so still you will be having a full percentage of health to fight against your target. Okay, so what we did, we just we just given small modification in a program. It's called as a hooking. We just modified the execution flow of the program, and we just uh, we just modified the health to 100. Okay, so so whenever we did some kind of hooking in a gaming applications to change the health to make the consistent health like 100 percentage, you can you can continuously play the game. Okay, so this is called as the game hacking or something. Okay, so by the method of hooking you can easily achieve that. Okay, the same way in cybersecurity, the defense evasion tactics, the defense evasion programs, it will be doing some API level hooking to hide from antivirus softwares or EDRs programs. Okay, so let me give a small example of how the hooking will be works in the real time. Um, so I have a Bitdefender antivirus program in my machine, so you can see here. And let me go for a task post. So here you can see the application taskforce.exe. And here you can see the handles, DLLs, threads has been loaded. So if you see this DLL, DDHKM64.dll, bit defender hooking DLL, so it was involved in the process, right? It was involved in the task host.exe process. Why the bit defender involving in task host.exe? What bit defender is doing here? Okay, so let me give a brief explanation. Okay, so let's take an example. I was developing a program, malicious code. So that code will be going to inject a malicious shell code into the task host.exe. Okay, so whenever we tries to inject our malicious code into the task host.exe. So what we will be doing, we will be calling some kind of API functions, right? Like virtual lock of, write process memory of, create remote thread of. Okay. So EDRs will be monitoring these API functions, and it will be stopping us, right? It will be stopping us, right? So in the back end, EDR monitoring the process, right? EDR monitoring the process. How EDR monitoring the process? How EDR knows our malicious program is going to inject something into the task host.exe? How EDR knows? How EDR understand what was going in the background of the process? Okay, so the hooking is coming into play. Okay, so the antivirus software hooked some DLLs into the application taskhost.exe, and it was completely monitoring the process. Okay, so now the EDR know what was going inside the process, what was the IP communication going on, what is the DLLs calling, what is the API functions calls are going on, what was the syscalls going on. Everything EDR come to know the entire process, the backbone of entire process. Okay, so by the hooking technique, the EDR can completely monitor the process, including the APIs, IP communications, contents, code, etc. Okay, so now I already said, so EDR will be one of a powerful tool. It will be it has a capability to do anything inside Windows. It can hook any kind of process. Okay, so in our example, we just see in the taskforce.txt that was hooked by the Bitdefender hooking DLL process. Okay, so whenever the Windows boots up, the Bitdefender loads a DLL file by calling load library of DLL, and hook the DLL inside the taskforce.txt. Okay, by this, so whatever the application was doing, the EDR comes to know, the EDR or antivirus software comes to know what was happening inside the process. Okay, so now I hope you have a clear understanding about the hooking. So what was hooking, and how the EDRs and antivirus softwares will hook. Okay, let's take an example of real world, how the malware is going to be react, and how the EDRs will be reacting. Let me give you a very brief explanation how it will be happening. Okay, in the superb example, with the super example. Okay, so let's take an example of our day-to-day activities in the home. Okay, not a home. Let's take an example of a restaurant. So the restaurant has a kitchen, right? So inside the kitchen, everything has been performed, like, right? Uh, the cooking, the cleaning, managing, everything, right? So the kitchen. Okay, so the next part of the kitchen will be the head staff. Okay, one of the head chefs is commanding what needs to be done. Head chef, right? The head chef, who will be coming, and next part will be the waiter. Okay, he will be. So we are the customers, and we'll be ordering to the waiter, right? I need a pizza with more cheese or more chicken. The chicken needs some tomatoes, onion, or whatever, right? So we'll be calling the waiter and we'll be ordering, and we are the customers, right? So this is okay. So let's take an example. The kitchen as a kernel in our machine. Okay, we will be calling the kitchen as a kernel, and the head chef as the NTDLL. So we know what is a NTDLL, right? NTDLL dot. This is a DLL file which holds an important API functions which will be used by Windows. Okay, and we can call the waiter as a kernel32.dll. Sorry, I was taking some time. I was drawing in the touchpad. Okay, okay, and the human as a application. Okay, you can call the application as a Chrome or task host or whatever. Okay. So let's take an example here. Okay. So our program telling to the waiter, okay, uh, our program telling to the kernel32.dll, like I want to save a file. I need to save a file. Okay. So you are downloading something from a Chrome, and the file needs to be saved in download folder. So your Chrome calling, I want to save a file. Okay. And it was telling to the kernel.dll. Okay, so it's not a kernel 32. Okay, let me draft that kernel32.dll. And what the next step? So your kernel32.dll calling the head chef, okay, the ntdll, and it was telling the application needs to save some file. Okay, so what the head chef will be doing, the head chef will be calling the syscall, okay, direct syscall, and he will be reaching out to the kernel, and the head chef, the ntdll will be saying to the kernel, like the application needs to save some file. Please allocate some space and help them. Okay. So the kitchen directly got the order and he is cooking. The same way your application commanding to I want to save a file to kernel32.dll, and your kernel32.dll reaching out to the ntdll, the lower API function. It's a higher level API. The kernel32 dll was a higher level, and it was calling to the lower level API function, the head chef, and that was ntdll.dll, and ntdll.dll giving a syscall to the system call to the kernel, and saying the application needs to save some file. We needs to do some help there. Okay. So whenever you needs to interact with the hardware, so you are saving the files to the hardware, right? Hard disk. That was a physical parts in our laptop, right? So if you want to interact with the hardware, the operating system, the Windows will not have a capabilities to do that. Okay, so only the kernel can able to communicate with the hardware as well as the operating system. Okay, it was it was the it has an intermediate, it was an intermediator for the hardware as well as the Windows operating system. Okay, so the kernel only can able to allocate some memory inside the hard disk. Okay, the same thing happening here. So the kernel, like the kernel, when the head of the ntdll.dll called a syscall, so the kernel goes to the hard drive, and he and it was doing, and it was giving some space to save the file. Okay, so only the ntdll.dll can only call the syscall. So the kernel will be only responsible for syscalls. Okay, only it was uh, communicating through the syscall. Okay, so the kernel only need a syscall for a communication, so to allocate a space to do anything. Okay, so this is the entire overview what will be happen. So once you call anything inside the program, even in notepad you are writing something or anything. Okay, so let's take an real-time example. So there is a notepad, and that was an application, and the notepad was calling the write file of API function. It was going to the writer. Okay, and it needs to write some file. And what the kernel was doing, so it was calling an API function w write file. Okay, write file of, and the waiter going with the head chef, and he's saying this notepad needs to save some file. Okay, the suddenly the API, so this all the higher level APIs. Okay, write file of. Okay, and the ntdll, so once it reaches to the ntdll, so the API will be changed to the lower level API nt. Okay, it will be adding nt native write file of. Okay, so nothing gets changed, only the API functions will be changed. So this all the lower level API functions. So this all the lower level APIs. Okay, so this the higher level write file of, and the NTDLL was a lower level APIs. Okay, and once the lower level API gets called, so the next part will be the syscalls. Okay, the syscall will be calling, and it will reaching out to the kernel. Okay, so this is the entire cycle of hooking. Okay, so in our scenario, what our mid defender software did. Okay, so our EDR or antivirus software, it will be creating guard. It will be acting as a guard after the kitchen. Okay, so it will be the EDR will be staying here. EDR or AV antivirus software will be staying here, and it will be watching what was happening in the backend. So what APIs was calling, so what was going, and what needs to be saved in the download folder, what needs to be write in the memory or anything. So it will be watching everything. Okay, it will be hooking, and it will be watching each and everything. Okay, so now let's see which functions, which API function EDR hooked. Okay, the EDR hooked the lower level API function NT write off, right? So it hooked the NT write off API functions and watching what was happening in the programs, right? Because it was intermediator for the head chef, and it was intermediator between the kitchen and the head chef. Okay, so in between one API is going to be called the NT write off function that was helping us is called, and this needs to be called. So okay, so the EDR understand each and everything. It was hooked the NT right of API functions, right? So it hooked. So now let's take a real-time example. Let me show you something. Let me open a notepad here. So I can explain. So what will be done. Let me open what is actually a cooking. Okay, let me open a x64 debug and let me attach the notepad here, and let me go for a memory map, and let me redirect to the uh, text format, text resource. So yeah, follow in disassembler, and here you can see here you can see the bytes 40 is to 55, and the text section was pointing towards the BCE 1000. Let me open a process hacker, and let me go to the notepad here and load the notepad, and let me search for notepad.exe. So here you can find the same address B75 BCE 1000, right? BCE 1000. Let me expand this. Okay. So here you can see the same memory uh, functions, right? Same bytes. 40 is to 55. Then CC8 D. Uh, Second. Sorry for the previous one, because I already set a breakpoint there. So now you can see the 40 is to 55, and the next byte was 48, 8D, 6C, 24, C9, right? So here you can see the 40, 55, yeah, 40, 55, uh, 48, 48, 80, 60. Okay. So what I am going to do, I was setting a breakpoint. Okay, breakpoint and toggle. So now the breakpoint has been set towards this address, and so what we are going to do, we are going to hook this. Okay, so we are going to change the execution flow of that flow of this program. Okay, let me go to the process hacker, and let me give a reread. So now you can see the bytes has been changed 40, 55, and CC. So previously it was in the 40, 48, right? So now we can see the CCU has been involved, right? But in before it was a 48. Before I set to the breakpoint, before I setting a breakpoint, it was in the 48. Now it was CC. We just changed execution flow, right? Uh, of the program. So now, so if I execute this program, so what the program will do, it will be redirecting to the debugger, right? Because I set a breakpoint there, right? It will be stopping there. Okay, there is a breakpoint, so the program execution will be stopped, and it will be waiting for a next command from a debugger. Okay, so this is called as the hooking. We just changed the execution flow, right? So we just stopped the program from the execution by setting a breakpoint. The address has been changed to CC. The bytes has been changed instead of 48. Here you can find a CC after 40, 55. 48 will be there, but now there is a CC. So now you can see the execution flow has been changed. Now the flow was redirecting to the debugger. So now you can feel how hooking will be, how hooks will be worked. Okay, so this is how the EDRs and antivirus softwares will be hooking and it will be monitoring for what you are doing in the application. Okay. So now let's see how we can bypass the antivirus softwares using the hooking method. Okay, let's go to the draw and take an example. Let me erase this. Give me a sec. Yeah. Now let's take an example about how we need to develop our program here. Okay. So there is a malicious application you are developing. This malicious app, mal app. So mal.exe. Okay. So once you calling any kind of API function like kernel 32 based functions like write file off. So your mal.txt will be going to write a ransom note readme.txt or something. Okay. So your kernel 32.dll will be calling write file of function, right? Write file of function. So once the write file of function get called through the kernel32.dll, so it will be redirecting towards the heads of ntdll to the function named ntWriteOff. So the important thing we need to monitor, the EDR will be hooked the NT write-off functions. Okay. So now whenever your program calls the NT write-off functions, EDR knows what was going inside the background. It was completely monitoring what was going inside the background. Okay. So whenever your program calls your mal.exe calls the NT write-off function, so the EDR coming into play and it was watching what was going inside the program. Okay, it have a capability to stop terminate your process, even it can do anything. Okay, so now what we can do, we need to bypass this step, right? We need to bypass this step. Instead of calling NT write of the lower level API functions, so what our program needs to do, it needs to it needs to directly call the syscall, okay, through the syscall number. For example, the syscall number of ntWrite of function will be 0x65. This was a byte. Okay, let's call this was a syscall number of ntWrite of function. So our program needs to call the 0x55 and it needs to reach out to the kernel. Instead of calling a function, API function, you needs to call a syscall number. Okay. So by calling the syscall number, you can easily bypass the EDR EDRs. Okay. So now the EDR doesn't know what was going inside, what was happening inside the program. Okay. So uh, you will be reading a syscall. How you got to know what was the syscall number? Okay, so whenever you started running the application, okay, so application, you need to collect a syscall address. Okay, so the syscall address will be hiding inside the ntdll .dll function. So you need to read a syscall from ntdll functions whenever you started executing whenever your program was in the execution mode. Okay, so that will be the only method uh, you can easily bypass the uh, EDRs. Okay, so this will be the only step. I hope you have understood explanation about the hooking, so how it will be happening. Okay, so the last time, so instead of calling the API function directly, we can use a syscall number 0x55 and we can, it's an example 0x55, and we can call the kernel. So this is the way you can easily bypass the EDRs without monitoring what you are doing. Okay. So you need to read the syscall number whenever your program was in the runtime, and you need to call the syscall and syscall number, and you can directly reach out to the kernel instead of calling the lower level API function. Okay. So I hope you have enjoyed this video, and we can see you guys in the next video. Bye bye.